High energy density and durability are characteristics that make any technology enthusiast wonder if the future is already here. Imagine a battery capable of withstanding up to 15,000 recharge cycles before showing signs of wear. That means decades of reliable use, whether in electric vehicles or in stationary energy storage systems. While lithium-ion batteries are known for their impressive energy density, aluminum-ion batteries offer a different proposition. Less focus on longevity and more stability over time. It's as if, instead of changing your cell phone every 2 years because a battery no longer lasts as long as it used to, you could count on the same device for the rest of your life. It seems almost magical, but it's pure science. The secret lies in the chemistry of these energy accumulators. They use metallic aluminum in the anode, while the cathode can be composed of graphite or inductive polymers. This configuration minimizes common problems, such as degradation and overheating, two major challenges of lithium batteries. In addition, the chemical stability of aluminum ensures more efficient and consistent charge cycles. Now imagine driving an electric car for years without noticing any loss in battery performance. Sounds too good to be true, but science confirms this possibility. The high energy density of these batteries also opens a door to applications far beyond electric vehicles. Stationary energy storage systems, used to stabilize power grids in remote regions, could benefit greatly from this technology. With greater energy storage capacity per unit weight, it is possible to imagine entire cities running on clean energy stored in aluminum-ion batteries. This not only reduces dependence on fossil fuels, but also makes electricity supply more reliable. Another fascinating aspect of these batteries is the speed at which they can be recharged, which could completely transform the experience of those who use electric vehicles. Imagine plugging your car into a socket, grabbing a quick coffee, and when you return, it is ready to drive hundreds of kilometers. It is almost like charging a cell phone, only on a much larger scale. This speed solves one of the biggest challenges that still prevents the mass adoption of electric vehicles: the waiting time for recharging. The secret behind this ultra-fast charging lies in the materials used. Electrolytes, whether liquid or solid, are designed to enable extremely efficient ionic conduction. This means that aluminum ions move between the electrodes at impressive speeds, without compromising the stability or safety of the system. As a bonus, this process generates less heat, reducing the risk of overheating during fast charging, a technical detail that makes all the difference in everyday life. This agility also redefines the experience of traveling long distances in an electric car. Today, many people still see long trips as a challenge due to the time spent waiting for the battery to charge. But with this new technology, this problem could be a thing of the past. Imagine making a quick stop at a service station, stretching your legs, and when you return, your car is ready to go. This innovation could change the perception of those who still consider electric vehicles impractical for traveling. And it's not just cars that benefit from this speed. Stationary power systems can also take advantage of this technology. Imagine entire neighborhoods or businesses charging backup batteries in a matter of minutes, ensuring a stable supply of electricity during blackouts. In a world that is increasingly dependent on electricity, this speed can bring greater safety and convenience to everyone. In addition, the convenience extends to urban planning. With batteries that charge so quickly, cities can completely rethink their charging infrastructure. Smaller, simpler stations could serve a greater number of vehicles, reducing costs and optimizing space. This change would also have a positive impact on traffic in urban areas, reducing queues and congestion at charging points. This technology has the potential to eliminate so-called range anxiety, one of the main concerns of those who drive electric vehicles. Knowing that a full recharge can be done in just a few minutes brings a freedom that electric vehicles have not yet been able to fully offer. This confidence in the charging infrastructure could be just the incentive needed to convince more people to migrate to this new era of mobility. Another interesting impact is on the way we view time. With ultra-fast charging, vehicles can be used more efficiently, reducing long stops between trips. Commercial fleets, for example, can take advantage of this technology to keep their cars on the road practically all the time, increasing productivity and reducing operating costs. This shows how this innovation goes far beyond individual use and can transform several sectors. In addition to practicality, the charging speed represents an essential step for electric vehicles to be adopted on a large scale. More than just a benefit, it is an advance that accelerates the transition to a more sustainable transportation model. With less downtime and more time on the road, electric vehicles are finally achieving the agility that many thought was impossible. Another factor that stands out is the economic viability of aluminum-ion batteries. Imagine a technology that not only improves performance but also drastically reduces costs. This is attractive to both consumers and manufacturers. Compared to lithium-ion batteries, aluminum batteries use cheaper and more abundant materials, reducing production costs without compromising quality. This balance between affordability and efficiency is rare, but it could redefine the electric vehicle market. Aluminum, which is widely available and recyclable, is a major contributor to this cost reduction. Unlike lithium and cobalt, which rely on mining in remote locations and often raise environmental and social concerns, aluminum can be extracted and processed more easily and cheaply. In addition, its abundance ensures a stable supply and avoids the risk of shortages, helping to keep prices under control in the long term. This creates the ideal scenario for making electric vehicles a viable option for a much wider audience. Cost reduction has a direct impact on the final price of electric cars. Today, one of the biggest obstacles to the mass adoption of these vehicles is the high initial cost. With cheaper batteries, automakers can offer more affordable models without compromising quality or performance. This puts electric cars on an equal footing with combustion vehicles, eliminating one of the main barriers to their popularization. It is not difficult to imagine a future in which an electric car is as common as a compact hatchback. And the benefits do not stop with consumers. Automakers also benefit, as the production of aluminum-ion batteries is less complex and requires fewer resources than lithium-ion batteries. This means higher profit margins or even the possibility of investing more in design and technology. In addition, with lower costs, these companies can better compete in emerging markets, where price is a decisive factor for consumers. Another positive point is the charging infrastructure. Since aluminum-ion batteries are cheaper and more durable, charging stations can be designed more economically and efficiently. This allows governments and businesses to expand their charging networks without compromising their budgets. In this way, the affordability of electric cars is not limited to the cost of the vehicle alone, but also to the ease of keeping them charged. Finally, this savings opens the door to innovations in other sectors, such as renewable energy storage. Home or commercial systems that rely on batteries to store solar or wind energy can become more affordable, accelerating the transition to a more sustainable energy mix. Imagine families installing solar panels combined with aluminum-ion battery systems, significantly reducing their electricity bills while contributing to a more sustainable future. The impact of this technology goes far beyond the transportation sector. Another key factor in its economic viability is the potential for reusing these batteries. Since aluminum is highly recyclable, manufacturers can create a more sustainable and efficient production cycle. This not only reduces manufacturing costs, but also minimizes environmental impacts, establishing a business model that benefits both the economy and the environment. In addition, the recycling process can boost job creation in specialized sectors, strengthening local economies. The cost reduction provided by these batteries not only encourages more consumers to adopt electric vehicles, but also accelerates the global transition to cleaner energy sources. With more affordable prices, the technology becomes more democratic, allowing a greater number of people and companies to participate in this transformation. It is a cycle of continuous benefits, where innovation and economy go hand in hand. The energy revolution driven by aluminum-ion batteries could also completely reshape the electrical infrastructure of cities. Instead of large charging stations, this new technology enables strategically distributed ultra-fast charging points, making refueling more accessible and efficient. More than just modernizing, the idea is to create a system that can keep up with the demands of an increasingly electrified world. These batteries can also be integrated into the electrical grid in innovative ways. With high storage capacity and long durability, they help to balance the energy supply, especially during peak hours. This means that entire neighborhoods could operate with stored energy during the night or during periods of low generation, eliminating fluctuations and offering greater energy security for homes and businesses. Another important aspect is the impact on public transportation. Electric trains and buses, which previously faced challenges related to autonomy and recharging time, will be able to operate almost continuously. With faster and more efficient charging stations, vehicles will always be ready to meet the growing demand of cities. In addition to improving urban mobility, this change contributes to a significant reduction in pollutant emissions, making the air cleaner for everyone. Parking infrastructure can also evolve with this new reality. Imagine garages equipped with ultra-fast charging points in every space. This would not only make charging more accessible, but would also optimize the use of urban space. Time wasted searching for a charging station would no longer be an issue, making the experience of driving an electric vehicle even more convenient. And the benefits are not limited to cities. In rural and remote areas, where electricity can be scarce or unreliable, aluminum-ion batteries offer practical and reliable solution. They can power entire communities, ensuring continuous operation of essential systems such as hospitals and schools. This advance goes beyond comfort. It is about creating real opportunities to improve quality of life. The private sector also has a lot to gain from this transformation. Businesses that depend on a continuous supply of energy, such as data centers and factories, can benefit enormously from this technology. With reliable and affordable storage, operating costs are reduced while dependence on non-renewable sources decreases. This creates a positive cycle where economy and sustainability go hand in hand, driving a more efficient and environmentally friendly future. The versatility of aluminum-ion batteries allows them to be integrated into microgrid systems, promoting more efficient energy distribution. Imagine entire communities or small neighborhoods operating almost exclusively on locally stored renewable energy. This decentralization not only eases a burden on conventional power grids, but also makes the electricity supply more resilient in the face of blackouts or natural disasters. This transformation in energy infrastructure marks a new chapter, where electricity is no longer just a resource but a fundamental element for mobility, urban life, and the sustainable functioning of cities. With aluminum-ion batteries, the transition to an electric future is not only gaining momentum, but also becoming inevitable. One of the greatest benefits of this technology is its smaller environmental footprint, especially when compared to lithium-ion batteries, which currently dominate the market. The impact is not limited to technical performance, but also the way in which resources are extracted, used, and reused. Aluminum, being abundant and highly recyclable, presents a much more sustainable alternative to meet the growing demand for energy storage. It is like offering a relief to the planet in the midst of the race for greener technologies. Aluminum extraction has a significantly lower environmental impact compared to lithium, cobalt, and nickel, whose mining operations often affect fragile ecosystems. In addition, the aluminum recycling process is extremely efficient with minimal material loss, which means that these batteries can be reused countless times. This drastically reduces the need for new mineral exploration and, consequently, damage to soil, water, and biodiversity. Another crucial point is the durability of these batteries. With a lifespan of up to 15,000 charge cycles, they need to be replaced much less frequently, reducing the generation of electronic waste on a large scale. This advance addresses two challenges simultaneously. It reduces dependence on raw materials and reduces the disposal of waste that could pollute the environment. The carbon footprint also comes into question. Lithium-ion batteries are energy-intensive to produce, while aluminum-ion batteries are cleaner and more efficient to manufacture. For those concerned about reducing greenhouse gas emissions, this difference is crucial. Imagine a world where every new battery produced not only saves resources, but also contributes to mitigating climate change. The sustainability of these batteries is not limited to their production, but also to their use. Their high capacity to store clean energy for long periods of time is accelerating the adoption of renewable sources, such as solar and wind. Regions that still face challenges in storing sustainable energy will finally have an affordable and efficient solution, reducing their dependence on fossil fuels and building a more balanced and resilient energy system. In addition, ethics in the supply chain gains more strength with this technology. While lithium and cobalt mining raises environmental and social concerns, aluminum presents a more responsible alternative, reducing the negative impacts of mineral extraction. This shows that innovation and sustainability can go hand in hand, creating a future where economy, technology, and environment are in tune. With this technology, many have heard about the precarious conditions in cobalt mines, where workers, including children, face extreme risks for minimum wages. With aluminum, this reality changes considerably. Its extraction takes place in more regulated areas, with safer and fairer working conditions, which reduces part of the social burden associated with battery production and allows for more conscious consumption. Another important point is the adaptability of aluminum to different climates and conditions. Because it is chemically more stable, these batteries present a reduced risk of catastrophic failures, such as explosions or fires. This additional safety is especially relevant in residential and industrial applications, where reliability is as important as performance. This is yet another example of how this technology manages to balance efficiency, sustainability, and safety. The large-scale adoption of aluminum-ion batteries is not just a technical upgrade, but a true paradigm shift. This is a solution that encompasses several stages of batteries' life cycle, from material extraction to disposal and recycling, meeting the demands of a world in transition, respecting the planet's limits and the needs of future generations. The technological and social revolution driven by aluminum-ion batteries goes beyond technical advances. It directly impacts access to and use of energy, affecting crucial areas such as transportation, education, health, and the economy. It is fascinating to imagine how this technology could transform life in regions that previously faced enormous energy challenges. What once seemed distant or exclusive now has a potential to become accessible to millions of people around the world. In the transportation sector, for example, the combination of durability and cost reduction allows the production and sale of electric vehicles in markets that were previously dominated by combustion engines, such as in developing countries, where price is a decisive factor. These batteries could open the door to the mass adoption of electric cars, which would not only be an environmentally friendly alternative, but also tools for inclusion, providing more affordable and sustainable mobility. Education also benefits directly, especially in remote communities or those without reliable access to electricity. These batteries could power entire schools, providing power for computers, lighting, and connectivity systems. Imagine a classroom in an isolated village where children can finally access the internet, learn from digital resources, and connect to the world. This would represent a significant leap forward in reducing inequality, opening up opportunities that previously seemed unattainable. The health sector also benefits from this revolution. Clinics and hospitals in isolated areas could rely on reliable power to operate essential equipment, such as vaccine refrigerators and diagnostic machines. In emergencies, where power outages can be fatal, these batteries offer a life-saving solution. In addition, energy stability allows the use of advanced technologies in places that were previously limited by poor infrastructure. Another important impact is on the local economy. With aluminum available in many parts of the world, countries that previously depended on expensive imports to access battery technology can now develop their own industries, creating jobs and strengthening their economies. This movement decentralizes the market, making production more diversified and less dependent on large monopolies. It is a model that favors autonomy and sustainable growth. In addition, efficient clean energy storage acts as a catalyst for community projects. Imagine entire neighborhoods operating with microgrids powered by solar or wind energy stored in aluminum-ion batteries. These communities not only reduce their carbon footprint, but also gain independence from conventional energy networks, which are often expensive and unstable. It is a form of collective empowerment that redefines the concept of shared energy. The accessibility of this technology also has the power to impact small businesses and entrepreneurs. With cheaper and more durable storage systems, merchants can operate more efficiently, even in regions with unstable energy supplies. From local markets to small factories, aluminum-ion batteries provide the stability needed to expand operations and improve productivity. It is a transformation that reaches from the individual to the community level,